fix that right now. Okay, I believe I'm recording. Did anybody get a pop-up on your screen that says we're recording? Yes, okay.
I did. By the way, can you hear me now?
So for sake of the recording, for those of you who just
Yes, I
joined,
checked.
I'm halfway through the syllabus and I forgot to start the recording at the beginning. So I apologize for that. I don't know if the transcription will be available or not, but at least you'll have the recording from this point out. And in the future, by the way, if I forget to start the recording, maybe somebody can remind me. All right, back to this. The remote, when we're remote, Zoom sessions are not required and they will be recorded so that you can view them when you can. We also have online classes, and those are all online. That is to say, there's no session that you have to meet. It's just a shell and you work your way through it. That's not the case for this class. Assignments and labs, everything has to be digital. Well, of course, that's a given because we're not in a classroom and you can't easily turn a paper into me anyway. We are going to be using something called Packet Tracer. Packet Tracer is a simulator program that simulates routers and switches and other devices. It's an awesome program. In fact, you can do almost anything on Packet Tracer that you can do with a live router or switch, and it's just like doing it on a live router or switch. When you do Packet Tracer labs, you will have typically two files. One file will be the instructions, and often in the instructions, I will have a place where there are questions that I will ask you to answer. The other file will be from Packet Tracer itself. Once you have done the lab, you'll do a save or a save as and save your work in Packet Tracer and upload that file to me. I can then check that file, check your configurations and make sure that they work and that they are configured correctly. Some of those labs will be such that Packet Tracer will automatically grade them. Others of the labs, I will have to manually look at your configurations and figure out what you've done. Once in a while, the automatic graded Packet Tracer labs don't grade correctly. This is particularly true if you do something extra. So you say, well, I know that this command is a best practice. And so since it asks me to do such and such, I will do the best practice and I will put it in this way. And I will do this extra command. Well, that extra command may throw off Packet Tracer so that it doesn't grade it correctly. In those cases, I may have to go in and manually check it. If I don't, and you don't have the score you think you should have, or you think Packet Tracer misgraded something, you may have to contact me and ask me to manually regrade that lab. So just a heads up that Packet Tracer is not perfect in grading. Typically, you'll have to turn in both files. I will let you know when you don't need to turn in both files, both the instruction set and the Packet Tracer file. In some cases, there will be 2 or 3 Packet Tracer files to turn in. As far as labs and assignments, everything is due Sunday at midnight at the end of the week that they're assigned. So we have a bunch of week 1 stuff, and that will be due on the 3rd, October 3rd. So It says midnight. It's really 11:59 p.m. The reason I do that is because if I say midnight, it shows up on your calendars as not due until Monday. And that messes people up and they think, oh, it's not due until Monday. So that's why I make it 11:59 so that calendars will reflect that it's Sunday night. Quizzes are also due midnight. Midterms and finals also have to be completed in the week in which they're assigned, no late or midterms or finals. So I will accept late labs, assignments, quizzes. And again, because we now have an informal policy in our department of not being so strict on deadlines, I am not, at least this quarter, going to incur the deduction. I still have that in the syllabus here, mainly because I forgot to take it out, but this allows me the option, but I don't believe that I will be exercising that option. What else? Let's just look at what the schedule looks like in here. In the first week, this week, we're going to be looking at a review of basically the 179 material, CIS 179, internet working, the OSI model, and all of that kind of stuff, particularly where devices fit in the OSI model. And then cabling. There is some very important information about cabling in this section, because when you start to do your labs, you will have to use the right cable. And if you use the wrong cable, you will be misgraded, or I should say graded down, either by me or by Packet Tracer. So you'll have to know when to use a crossover cable and when to use a straight through cable and when to use a rollover cable. So all of these things are not just here for something to test you on. They are very practical. So we will be doing that here in the first week. And after I go through all of the course stuff, I will be going over a little of this in lecture, although I have a lot of very good videos that you can watch as well. In week 2, we are going to be covering that VLSM subnetting, that variable length subnet mask, which is a way of subnetting in a way that you minimize waste. So if I have 200 computers on one network and only 100 computers on another network, with regular subnetting, I would just assign 200 computers to each network. They'd all have the same size. But with variable length subnet masking, I can assign different numbers of computers to different networks and reduce the waste. Why would I need 200 IP addresses if I only have 5 devices on that network? We'll also talk about wildcard masks. Now, you won't use this information until way down here when we get to 10 and 11, OSPF and access lists. But you will want to learn it because we will use wildcard masks when we get to those sections. In 3, we will learn about route summarization, which is also called supernetting. This is used in routes that we program into routers. So a router has to know, well, where do I send a particular packet that's destined for 207.15.5.4? Where would I send that? If I had an entry for every possible IP address, that routing table would get very big. But by summarizing routes and saying, I know that no matter what network these go to, everything that goes to any of these 5 networks goes to this next router, then I can put all of those networks in one statement and say, well, we're going to send anything that goes to these 5 networks to this router. So it's a way of reducing the size of routing tables. In week 4, we will be dealing with IP version 6. Of course, IP version 6 is getting bigger and bigger and more common. I can almost guarantee you that your phone now communicates strictly in IP version 6. IP version 6 is now in most computers and most routers, although you can turn it off. And I believe that the networks at PCC have IP version 6 turned off at this time. But you do need to learn about it, and subnetting does not go away in IP version 6. I know you wish it did, because it's not easy to do. But actually, I think IP6 subnetting is easier than IP4 subnetting, personally. And why do we need it? Well, we still need to separate our devices. Let's say that I'm in an organization that has production on one network and payroll and HR on another network. I don't want those two to be on the same network. For security purposes, I want them to be on different networks. So I would want to subnet my network into 2 separate networks for security reasons. So that's why we need subnetting even with IP version 6. Starting with week 5 now, we begin actually doing stuff. So we're going to learn the iOS, that's the Inter-Network Operating System. Don't confuse it with Apple's iOS. This is Cisco's iOS. And then we will begin learning already at that point about basic router and switch configuration. There are several things for security purposes or in basic setup that you need to do before you begin doing other kinds of setup. Actually, I need to change this because I see I have basic router and switch setup down here in week 6. So I will change this. iOS and packet tracer. So in 5, you will learn about iOS and you'll learn about how to use packet tracer. And then in 6, we'll do those basic router and switch setups. In week 7, we will learn about port security. Port security is something you do on switches. If I have, say, 42 ports on a switch and devices, PCs, plugged into 20 of those ports, well, what about the rest of the ports? What about the other 22 ports? A person could walk up to that switch and plug a PC into any port on that switch and be on my network. I don't want that. I want to know who's on my network and not let the bad guy on my network. And so port security is the way we deal with that. For example, let's say that Joe Schmo brings his laptop to his cubicle at work and decides to plug his laptop into the outlet in the wall for the network, but his laptop has a bunch of viruses on it. He's now introducing those viruses or those worms into my network. So I can actually set up using port security a recognition that this is not a company device and shut down that port. It's really cool. So we'll learn about that in week 7. In week 8, we'll learn about something called Spanning Tree Protocol, or STP. We want redundancy between our switches. If a port or a wire goes down, we want our switches to be able to communicate through another switch. So we make many different connections between switches. But that creates something we call loops, and those loops create problems. So STP is the way that we stop those loops, and we'll learn about that in week 8. In week 9, we will learn about VLANs. Again, we're still dealing with switches. Switches have the capability of actually separating IP networks, so subnets. So we'll learn about those VLANs and how to do that on a switch. But if we do that, then we have a problem. Now they're on separate networks and they can't talk. You can't go from one network to another without a router. And so we'll learn two ways to be able to route traffic from one VLAN to another VLAN using routers. And one is called port-based and the other is called router on a stick, which is a cool name. In 10, we'll look at routing protocols. Routing protocols are ways that routers can automatically learn about routers nearby so they know where to send stuff. So if I have a packet destined for 200.100.50.1, where do I send it? What router do I send it to? Well, if I know what the routers around me are connected to, then I have a good fighting chance of figuring out where to send that packet. So OSPF, which stands for Open Shortest Path First, is a routing protocol, one of many routing protocols that we can use for routers to learn about each other. In week 11, we will take up access control lists, or ACLs. This is the way that we control traffic through our network. So if I have, again, certain networks, say my production network and my HR network, I don't want traffic going back and forth between those networks, except what if HR has a website, an intranet site, not internet site, but intranet site that is designed for production to be able to do things. Maybe it is for signing up for your medical benefits, for example. Well, I do want that traffic to be able to go through. So I can specify certain kinds of traffic are able to pass from one network to another using these access control lists. And all other traffic would be blocked in that case. So that's what ACLs are all about. But it's a pretty full schedule. And you'll see that for the most part, we just have a bunch of labs and then those command summaries I was talking about that you'll take all the new commands that you learn in these labs and you'll put them into a command summary and turn that in. And then a quiz, which will be based on notes and the labs. So that's what this class will look like. I'm going to open up my chat and see if we have any questions. I'm sorry, again, I can't hear you. The laptop froze, okay. Any questions? I am sorry that I couldn't take questions on the fly since you couldn't talk to me verbally. Okay, it doesn't look like any questions coming in. It's 4 o'clock. Let's take a break so that you can use facilities or get a snack or whatever you want to do. That's the nice thing about Zoom, right? You can sit there and drink your Mountain Dew, because all IT people drink Mountain Dew. It's a rule. It's a law. So let's take a break until 4:05, and then we'll come back and let's take a look at some of the material. I will not be at my computer here, so if you try to talk to me, I won't be available. Okay, we are back. Can everybody hear me okay? Somebody give me a sign in the chat if you can hear me. Yes, good, thank you. All right. All right, let's look a little at some of the material for this week. And I probably will not take the entire time until 4:50. Also, future sessions probably will not be nearly as long because we don't have all of this administrative stuff to cover. Module 1, short welcome video. All right. I am currently working on making sure we have captions on all of the videos. I didn't get the notification in time to have them done for me, and so I'm working on them myself. And as we get into these notes, if you take a look at these notes, you'll see I have video after video after video after video. And so it's a lot of work. For future weeks, I'll probably have that done for me. But right now, at this point, I have all of the captions done for Internet Working Review and Ethernet and data encapsulation, but I don't have them done yet for network cabling. In the introduction, yeah, I had to make sure that's the correct link. For the introduction, we just talked about what we're going to deal with this week. And by the way, I should let you know that future modules, I don't have everything put together the way it will finally look in those modules at this point, because I just came out of the summer quarter, which is only 8 weeks long. So I have to juggle some of this stuff around, and I haven't juggled around everything for future modules yet. Over the next couple of weeks, I'll be doing that, but you can't see those modules anyway. But if you open the content and you see the, you see the information, you just can't click on them. They may be incorrect. So give me a couple of weeks to get all that straightened out. But you can see we're going to do the Internet Working Review, data encapsulation, cabling, and that kind of stuff. Let's go back here to the notes and look at this Internet Working Review stuff. And I want to point out some of the most important of these things, and maybe even talk a little bit about some of them that I don't think are as clear as they should be on the videos. We talk about what is a network, and I don't need to go into any more detail on that. And what is an internetwork, which is a network of networks. There's a very fine difference between hosts and nodes. And again, I'm not going to go into that right here because it's not as critical as some of the other information here. Intro to protocols. I do want to talk about this one a little bit. When we say protocol, we're talking about a standard of some sort. In a sense, you can talk about languages as protocols, right? English is a protocol, Spanish is a protocol, and so forth. In order for a protocol to work, it means that two sides have to speak in that same standard. If I speak English and you only speak Spanish, we're going to have a hard time communicating. The same is true of computer communications. If one computer says, well, it puts out a series of ones and zeros that represent its IP address, the other computer needs to know that that is the place in which it's expecting to receive an IP address. Otherwise, it doesn't know what those ones and zeros are, what they mean. They could mean a color or a letter or a number. So the protocol specifies, well, first there are going to be so many bits of IP address, destination IP address, and then so many bits of source IP address, and so many bits of a sequence number. So when the receiving computer receives it, it says, okay, these first bits are a source address, these bits are a destination address. So that's the protocol. The order of the pieces of that header are represented in that protocol. There are hundreds of protocols in play at any given time, and they overlap with each other. When I was beginning to study networking, this threw me off. I could only think of one protocol at a time, but there are lots of protocols in play at the same time. Again, if you think about language, there are many protocols at play right now as I speak. There are choices of words, the vocabulary. There is grammar, that's a different protocol. If I were writing, there would be a spelling protocol. And they're all overlapping with each other. They're all existing together at the same time. One protocol may call upon another protocol for it to work. An example of that in the computer world would be IPsec, that's IPsec. IPsec is a security protocol, but really it's a suite of protocols. It calls upon an encryption protocol, and it calls upon an authentication protocol, and so on. So it calls in several other protocols. So it's a suite of protocols in itself. TCP/IP is a suite of protocols. And any given point in the OSI model, many different protocols may be used. However, certain protocols exist within certain levels of the OSI model. Now, I know you've had OSI model theory before in CIS 179. That's why I'm not explaining it in a lot more detail. But when you think TCP/IP, that's not a protocol. It's a protocol suite or a protocol stack. It's several hundred protocols that all exist and interact with each other in a nice way. OSI is simply a model for communication that you can apply to any kind of communication. I often liken it to a conversation. If I want to, let's say that I'll just pick on somebody. Jacob, you don't mind if I pick on you, do you? Let's say that it's Jacob's birthday. And I would happen to know, I don't know any of this, but let's say that I know that Jacob's favorite color was green and he loves frogs. And I really would like to make a cake for him. Well, I don't make cakes. And so I'm going to ask my wife, say, to make a cake. My wife is Giselle. And so I need to communicate with Giselle what that cake is going to look like. Well, the first thing I have to do is make a picture of it in my own mind. That would be what we would call the application layer in the OSI model. That's where the data appears. That's the thing that you want to communicate, where you create the thing that you want to communicate. In this case, an application is creating that. And then I have to decide how I'm going to communicate it. That would be the presentation layer. Am I going to write it? Am I going to put it in a text message? Am I going to go into the living room and tap her on the shoulder and say, excuse me, I'd like to tell you something? Am I going to call her on the phone because I'm not at home at the moment? So I have to decide how I'm going to present it. Is it going to be in writing and speech and so forth? And then I have to move down to the session layer. The session layer says, open a session, tap that shoulder, right? Or get her attention in some way. Now, the next ones, we don't really have a good correlation. The transport layer, the network layer, the data link layer. But these are layers where addressing occurs. So my analogy breaks down at that point, but let's change analogies for a moment. And let's say that I am writing it in a letter. In fact, let's say that I had decided I would write it in a letter because my wife happens to be in another state at the time, visiting a relative. So now I have to address it. And I have to have a couple of addresses. I have to have the destination address, and then I have to have a source address, which is the return address that I would put on the envelope. And then there is at the data link layer, a local address, which again, in my analogy, it doesn't work as well, but it's the local movement from my mailbox to the local post office. And then once it's at the post office, it goes across from one post office to another. That would be router to router. And then there's a physical layer. And that physical layer is whatever that transport actually is. If it's going by plane, by truck, by train, how is it actually traveling there? So you can see that this communication model actually fits any kind of communication, not just computer communication. And various protocols fit into that model at various places. But here's the tricky part. Not every protocol has a particular place that it fits very well. Some protocols may fit at different places depending on when they're used and how they're used. So in this OSI model, we introduced this OSI model like this as layers 7 through 1, application layer, where that ideation occurs, that data is generated, formatted, compressed, or encrypted. This could be turned into a JPG file or a GIF file or an HTML file. The session layer, which establishes and terminates the communication sessions, that's pretty much invisible as far as our data is concerned. But within the software, something is going on to get the attention of another computer. And then the transport layer, where end-to-end delivery takes place. And by this, I mean a port number. So end-to-end delivery is when a port number is placed as a header on that data so that when the receiving computer gets it, it knows what to do with it. If there's an 80 as the port number, then the receiving computer knows that this is web page data, and it knows to send that data to the browser. That's why we call it end-to-end, because it's all the way from the application on one computer to the application on the other computer. By the way, this is the first layer at which chunking takes place. We break that data up. Up until now, up until layer 5, it was just a stream of data. But now we're going to chop it up. And by the way, my video is not on, I noticed. I don't know why. We're going to chop it up into what we call segments. And each segment will have that port number put on it. It will also have a sequence number put on it. Imagine that I decide for some reason to spread my communication with my wife out over many envelopes. Maybe it's some sort of a birthday gag or something, and I want her to receive a whole bunch of envelopes, but she's visiting her sister in California. And I want to make sure that when she gets the envelope, she knows what order to write to open them. So on the back of that envelope, I write a 1 on the first envelope and a 2 on the second envelope, and so on. That's the sequence number. So that sequence number is put in that header at the transport layer along with the port number. The port number would be so that when her sister receives it in the mail, she knows who it goes to, right? My wife would be the application in that case. So the sequence number says, well, to the receiver, now this is the order you're supposed to open these things. At the network layer, we do the inter-network addressing. This is the IP address. So we're going to add the IP address of the final destination. In this case, in my case, it would be the address of my wife's sister's house. So that's the final destination. The data link layer also has an address, the MAC address. This is a local address. Now, we don't have a good analogy in real life, but imagine that in order to get my letter from my mailbox to the post office, my local post office, I had to have a local post office address, and I had to put that address on the envelope. So I would actually take my original envelope, put it in a second envelope, write the local post office's address on the second envelope, and send it. When the local post office gets it, it needs to send it to another post office, say from the Camas post office, which is where I live, to the Portland post office, a more central post office. So it would remove the inner envelope, write the address of the Portland post office on a new envelope, and put that envelope back in the new bigger envelope and send it to that one. Now that post office may send it to another post office, let's say the Salem post office. So it would have to remove that outer envelope, write a new address for the Salem post office, put the envelope back in the bigger envelope, and send it to Salem, and so forth. Now that's a very, very important point, because sometimes you'll see questions on tests, not giving anything away, I hope, that would ask how MAC addresses and IP addresses work. You might be given MAC addresses and IP addresses for various machines from source to destination, and asked something like, when this packet arrives from, leaves this computer and arrives at this computer, what is the MAC address and what is the IP address at that point? So you have to realize that from every router to the next router, the MAC address changes, but the IP address stays the same through the entire process. So local transport is the network, and inter-network transport is at the, local transport is at the data link. Inter-network transport is at the network. So the network layer has that IP address. The data link layer has that MAC address. I said that at the transport layer, we call this a segment. At the network layer, we call it a packet. And at the data link layer, we call it a frame. These are very important terms to know because if you actually go into the networking field, you use these terms every day. And if you misuse them, you will confuse people. If I say this packet didn't arrive correctly, my coworker will immediately know that I'm talking about an IP address and a router. I am not talking about a switch. Switches occur at layer 2. They deal with MAC addresses. Routers occur at layer 3 and deal with IP addresses. So when we communicate in this field, we have to be extremely careful about the terminology segment, packet, and frame. Occasionally we make a mistake, and occasionally I'll make a mistake in this course. I've tried to fix that in my videos to make sure that I refer to them correctly. One problem is that in the general public, we call everything a packet. We've learned that the word packet simply means a chunk of data that we communicate with on computers, and we use it as a generic term. Be careful not to do that now that you are an IT professional. It is a frame if it's a local traffic on a switch, and a segment if it's a transport layer chunk. At this point, I want to ask, it just so happens I'm reading the comments in the chat here. I can hear all pizza served today needs double pepperoni. Well, there again, it's a law that IT people must eat pizza or Hot Pockets, one or the other. Just so happens that green is my favorite color, and I'm also quite fond of frogs. Thank you, Jacob. See there, I'm psychic too. The TCP model. So it turns out that the TCP IP suite of protocols doesn't fit the OSI model very well. And so some people set out to fix that and create a new model called the OSI, or called the TCP model. Sometimes it's called the TCP IP model. Don't get it confused with the TCP IP protocol. One's a model, one's a protocol, or a protocol suite. Because as network professionals, we don't really deal with the session and presentation layers very much. We put those all together into one group called the application layer in the TCP IP model. The transport layer is still called the transport layer. The network layer in the OSI model is called the internetwork layer in the TCP IP model. Sometimes you'll see it written as only the internet layer. And then the data link and physical layers are all put together into one layer called the network access layer, or sometimes called the network interface layer. So you can see we can get confused. If I say network layer, I have to be very careful not to say network access layer or network interface layer if I'm talking about OSI model. And I need to be very careful about making sure that you understand what model I'm talking about. Although it turns out that the protocols fit better in the TCP IP model than they do the OSI model, it turns out that the OSI model is sort of set in everybody's minds to the point where they almost exclusively still talk in terms of the OSI model. I've seen a few books that the author has tried to be current and use the TCP IP model in their terminology, but you'll hear OSI model terminology almost strictly in the field. We don't use numbers in the TCP IP model. We don't say the transport layer is layer 3, for example. The transport layer is always layer 4. We always refer to them by number in the OSI model. In the IT field, how often do you actually hear those numbers? How often do we actually talk about the OSI model and these layers? The answer to that is every day, literally every day. I was once in a class that had in it a professional, networking admin professional, who was just trying to get a certification. And the teacher asked the student, how often do you use, layer 2, layer 3, layer 4 in speech at work? He said every day, many times a day. So get used to them. You need to know these things so well that you can quote them in your sleep. And as soon as somebody says layer 2, you should immediately know we're talking about switches. We're talking about MAC addresses. You know what's in it, a destination MAC address, a source MAC address. You know that there's a trailer, and that trailer, this is the only layer that has not only a header, but a trailer. And that trailer has a cyclical redundancy check, CRC. All of that stuff should come to mind as soon as you hear 2. And as soon as you hear 3, you immediately know we're talking about IP addresses, routers. As soon as you hear 4, you know we're talking about sequence numbers and so on. So get to know these. A very common one is layer 1. One of the most common mistakes that people make in the lab when they're first learning is layer 1 connectivity problems. You won't have this problem as much in using the packet tracer simulator as you would if you were using live routers and switches. But particularly when you're using live routers and switches, you plug all these cables into all these little holes and you get one in the wrong hole and things don't work. That's a layer 1 problem, cabling problem. By the way, I don't know if you've all seen routers and switches, what they look like in the real world. I have one. I have a router right here. See if I can get it in the camera so you can see it there. So there's not much to it. On this side, you see I've got no ports at all. I don't know if you can see that, but there are no ports on this side. On the back side, which is really more like the front side, I've got a switch here, and I've got a port called the console port right here. And I don't know if you can read that, but it says console right there. That's what I would plug my computer into in order to configure this device. And then I've got 2 ports here, and these 2 ports are different networks. So one port would go out to a switch that connects to one network, a group of computers, and then the other port would go out to a switch that connects to another group of computers. I don't have a switch sitting beside me. Oh, maybe I do. I do have a switch sitting here. I didn't think I did. I got a stack of them out here. So here's a switch. And the big difference is, of course, about a billion ports. Well, not a billion. There are 24 ports on this switch. And then on the back side of this switch is the console port that I would use to plug in my computer into in order to configure it. And that's it. One interesting thing on this switch and every switch that you might notice is there's no on-off button. There's no switch to turn it on and off. Switches don't have one. As soon as you plug it in, it's on. Another interesting thing about switches is that as soon as you bring it up, it's ready to use. You can plug computers into it. The ports are all open. Everything will run just fine. But routers is a different story. the ports on a router are shut down by default and you have to start them up. We'll learn about the commands to do that, but here's a spoiler, which is always a fun one. How do you command a port to turn on? Well, here's the clue. The command to shut it down is shutdown, which, by the way, you can just type shut because you can abbreviate commands. And so if you want to start it up, you type no shut. That's the startup. It's funny, but that's it. Anyway, so here's a TCP IP and OSI model comparison. Protocol data units. I already talked about protocol data units. It's data for 7. Layer 6 is data. Layer 5 is data. Layer 4 is the segment. Layer 3 is the packet. Layer 2 is the frame. And layer 1 is the bit. Headers and trailers. So what we have going here, let me see if I can switch over to another screen. What we have going here is, let's see, this thing is not going to allow me to draw. There we go. Hopefully that'll, there we go. So here's my data up here. This is just a stream of 1s and 0s. When I get down to layer 4, I added that header on there. This is the transport layer header. This might be small. I hope it's not too small for you to see on your screen. I don't know. When I get down to layer 3 also has headers. This whole thing here, the header and the data, now becomes, as far as layer 3 is concerned, the data. So I'm going to encapsulate this. This is a layer 4 header with a layer 3 header. And then when I get down to the layer 2, this whole thing, as far as layer 2 is concerned, this whole thing is all one unit. And I'm going to encapsulate that with a layer 2 header and a layer 2 trailer. So this is encapsulation, and you can see that this thing just gets bigger and bigger and bigger as we go down. Now, once it goes from 7 down to 1, it goes across some wire or wireless system. The receiving computer on the other side strips off, well, it gets all the data here, and then at layer 2, it strips off this information, the layer 2 header and trailer, and now it's got a layer 3 packet. And then it strips off that layer 3 header, and now it's got a layer 4 segment. It strips off that header, and now it's got data, which the software pushes up through the session layer, the presentation layer, and then finally to the application layer. There is some bouncing back and forth. Remember that I said if I have a router, and by the way, this is the symbol I'm going to use for router for very quick reference. You'll see why later when we actually look at the symbols for routers. It's something like this, but I don't want to draw all the arrows all the time. So I just draw a circle with an X in it. Remember that as I go, this is a switch. As I go to the switch into the router, I'm using the MAC address. But then as I go from a router to a router, I'm using an IP address. But I'm not actually addressing this router by IP address because this middle part here is a local network. This is actually a network between routers. So I'm actually using a MAC address to go from router to router. This IP address stays the same as I go all the way across, same IP, until it gets to the final destination. Here's a switch over here and a computer over here. When it gets to the final destination, that IP address is finally stripped off at this last router. But up until this point, every one of these jumps is by MAC address, not by IP address. So all these are local jumps. So you can kind of see it's jumping back and forth between layers 2 and layers 3. That was, remember earlier I mentioned the post office is going to take that envelope out of out of the larger envelope, put it in a different envelope and readdress it, take that out, put it in a different envelope and readdress it. That's the same thing I'm talking about here. Okay, I hope that makes sense since I can't hear your feedback. Okay, I go through each layer in a little more detail here. Network segmentation, broadcast domains and collision domains. Since we're running low on time, I'm not going to bother to go into these in detail right now. I think the videos do a pretty good job of it. But you do need to know how to count broadcast domains and how to count collision domains. Broadcast domains are separated by routers. So every port on a router is a broadcast domain. Every port on a switch is a different collision domain. Hubs, which are like early switches, don't separate collision domains. Now, I know you had this in 179, so I hope that you remember some of it. And if not, these videos should make it clear. But a collision domain simply means any devices that talk on, they're all connected on the same wire. And if they talk at the same time, there's going to be a collision and they can't talk at the same time. Something has to be done to make sure only one talks at a time. Now, I said that a switch is, every port on a switch is a different collision domain. So let's take a switch here, a PC here, a PC here, a PC here, PC here. 1, 2, 3, 4. That's supposed to be a 3. If every port here is a collision domain, I'm saying that PC1 is a collision domain, is on a collision domain. Well, what's it going to collide with? It can't collide with anything. It's the only PC on that wire. It's still a collision domain in that if for some reason I had a PC connected to that wire, it would collide. Of course, it won't because I can't have another PC on that. Or could I? Could I? Yes, maybe I could. Watch this. I'm going to have a switch and I'm going to run this switch to a hub. Now, hubs are like early switches. They don't separate collision domains. They're just like a big wire all wired together. So let's say that I put a bunch of PCs here on this hub and they're all connected to one port on a switch. These are all on one collision domain. And yes, they could collide with each other. So we say that every port on a switch is on a collision domain and every port on a router. The only thing you have to be careful of is a broadcast domain. So the only thing you have to be careful of is this is one broadcast domain. Yes, I know there's 2 ports here. There's a port on this switch, or a router. There's a port on this router. So routers separate broadcast domains. Switches separate collision domains. And again, there's more information on those videos. So I go through all those routers, hubs, switches, segments, what a segment means, LANs, WANs, CANs, PANs, WLANs, SANs. Okay, that's all the important stuff on this one that I really would like to talk about. We have 5 minutes left, so bear with me. Encapsulation, I've talked about quite a bit. I want to go down here to network cabling. Unexpected server response. Well, that's interesting. Okay, I don't know what's going on here, but something is. There are three kinds of cables that you're going to deal with in this class. Straight through, crossover, and rollover. A straight through cable has connectors at each end, of course, and there are 8 connections in that connector. 1 connects to 1, 2 connects to 2, 3 connects to 3, and so on. In a crossover cable, well, that's a bad picture. In a crossover cable, some of these, and I'm not going to go into the specifics because of time, but some of these cross over. Not all of them, but some of them. And the reason for that is if I plug this into a port, into a hole here, one of these connectors is a transmit and another one is a receive. Well, if these went straight through, I can't go from a transmit to a transmit. That wouldn't make any sense. I'd have to go from a transmit to a receive. And so I cross these over. When you would do this, watch the videos. I don't have the time to go into them now. The rollover cable is the one that I would use as those console ports in the switches and the routers. The rollover cable, 1 goes to 8, go like this. 1 goes to 8, 2 goes to 7, 3 goes to 6, and so forth. It's directly opposite. Rollover cable is a special cable used by Cisco for the console port. I don't know why they do it that way. I think part of it's security to make it a little bit more difficult for hackers. But at any rate, the rollover cable is the one that you will use when we connect a PC to a device in order to configure it. All right, that's about it. That's about for all of my time that I have today. I'm going to open up the chat here again. And is being a psychic an IT thing? I doubt it. Only when you're eating Hot Pockets, I think. I don't actually eat Hot Pockets. So I'm a bad IT person. I do eat pizza. I love pizza. Any other questions? No, apparently not. Okay, in future weeks, this will not be nearly as long. My videos do a pretty good job of covering everything. So if that's it, then we will end our session today and see you next week. And if you have any questions in the meantime, please, by all means, get a hold of me. Okay. See you next week.